Okay, so number 4 says, let R be the region in the first quadrant bounded by the graph y equals 2 square root x, the horizontal line y, and the y-axis as shown in the figure above. Okay, so A, find the area of R. When we're told to find area, the first thing we think about is integral. We got to get our integral, our bounds, and our top minus bottom, always. So first of all, everything that is given to us is in terms of x. So we're going to use our x coordinates for our bounds. So we have 0 to y, and we're going to do top minus bottom. I think it's pretty obvious that the top is y equals 6, and the bottom is 2 square root x dx. All right, or in other words, you can write 2 square root x like this. Next, we take the antiderivative, because this is a non-calculator question, and it asked for the area. It didn't just say write an expression. So the antiderivative of 6 is 6x. Antiderivative of negative 2x to the 1/2. You add 1 to the exponent, bring it down, multiply it by the constant. You can simplify that or not. And then you evaluate from 0 to 9. All right, so if you evaluate that out, you get 18. B asks, write but do not evaluate an integral expression that gives the volume of a solid generated when R is rotated about the horizontal line y equals 7. Okay, so I'm going to do this in green. Let me erase this so it doesn't get confusing. Green, okay. So y equals 7 would be right about there. And we're going to want to draw our inner and outer radii because it's rotating, so we have radiuses now. It's going to be a washer, so that's our inner radius, that's our outer radius. Now, what is the short radius actually? It is 7 minus 6. Because we have the top minus bottom, we want to find out this little area right here is 1. And then the longer radius is going to be 7 minus 2 square root x. Okay, so we have that established. So we're going to do pi first off because it's rotating. Everything is still in terms of x, so we're going to use our x bounds, 0 to y, of radius outer minus radius inner. Radius outer is the larger one, right here. Squared, don't forget to square because we're taking the integral of the area, which is going to give us a volume, of radius inner, right here. Squared, dx. And that's it. For C, the problem says, the region R is a base of a solid. For each y, where y is between 0 and 6, the cross-section of the solid taken perpendicular to the y-axis is a rectangle whose height is 3 times the length of its base of region R. Write, but do not evaluate an integral expression that gives the volume of the solid. Okay, so first thing that jumps out at me is perpendicular to the y-axis. So we know that we have to put our function in terms of y. So that's what I did right here. And you can just ignore y equals 6 because you can't really put that in terms of y. And it's irrelevant to our bounds. So then the second piece of information is that it's a rectangle whose height, oh wait, that was really bad. A rectangle whose height is 3 times its length. So first of all, rectangle. We draw our rectangle right here because Mr. Shan says always to draw your cross sections. And the base of the region R is its length. So that is going to correspond to this. Now, what exactly is this region? It's going to be the area of this function going down to the y-axis. So we've already solved for the function in terms of y. So x is the function in terms of y. And then the height is 3 times the length. If the length is this, the height is going to be 3 times that. And so when we're finding the solid, we're going to take the integral of the area right here. And so the area of this is going to be base times height, area. And then we take the integral of the area, but our bounds must be our y coordinates because everything's in terms of y. So 0 and 6 dy. A little trick is that, actually never mind, it's fine. That's it.